Awesome. It's a good day today. Great day today. So I got it maglev. Let me show you that. Kind of see it. All right. So we got circuit number 1. Primary circuit is hooked up. You get some tack reading on that. It's 750 RPMs currently. 800. Right. So it's going pretty fast right now, right? Like almost 900, maybe 900 RPMs. Now, hello. How we doing? 1,000. 1,250. Yeah, wow. Whew. Never seen it shake like that. Not with this rotor. That's awesome. All right, so let me explain what's going on here. Hello. All right, so we have 2 circuits here on the same wheel. We've got one with 31 volts, and that's this trigger coil, that 16 gauge coil down there, the red coil, which is 24 gauge, and this coil, which is 20 gauge. And that's a circuit that this light is attached to. So, and the rotor, which is I think the coolest part, it's got fan blades on it. Oh yeah, that, and it's magleved. Um, 4 neodymium cubes, but the cooler part is it's got this fabric softener on it. So all the air is sucked in and forced down through that stuff, and it makes the air smell nice, and we get any larger debris out of the room. I think it's cool. No, sir. No, I'm explaining what this is right now. You either got your sound off or you're not listening. Either way, you're not getting my point, which is it's an air filter and an air freshener. Basically, that's what it's doing right now anyway. You just spin it and it sucks all the air in. I'm going to demonstrate that real quick. Alright, so turn it on the 31 volt circuit. The light's going to get flashing in a second. Wow. So it kind of gives you an idea how the energy's flowing through. I'd say that's really choppy, you know? Yes. Yes. Yes, sir. That's it. Like an automatic Febreze, spinathon, mobile. Dude, it's awesome. A little over 800 RPMs. God, I wish I had like some green smoke or something. But I'm gonna get some real smoke here, just real quick. I got some of this. And we're gonna watch it, what happens. It's still pretty sturdy, isn't it? Yeah, it's still not shaking. Okay. And there's my Utron. I'm gonna hook that back up. I'm putting you guys in the tripod real quick so that I can use both my hands. I'm gonna move it up so you can see. Whoa, wasn't cool. Gonna take it out real quick and screw that back on. Okay. That's the 31 volts maglev. Wow, dude. That's cool. And then when I set up the other drive, you can get it like way up here. You still kind of get half of it when it's up there. But it'll take anything within the vicinity and suck it right through. At least as far as the shaft, you know, in all directions, really. And it forces it through the fabric softener, which filters it and uh, makes it smell nice in here. Oh, there you go. More bam. Now I have a signal generator hooked up to the other circuit, so I'm going to run that one real fast. turn that one off just for good measure. We'll turn the signal generator on. And it doubles the brightness output of the light in the corner. You can't really see it, but it's right there in the window. There we go. Wow. That was almost pulling 5 amps right there for how fast it's going. Yeah, that's 105 kilohertz going through there. And at that speed and this voltage, man, that's a tremendous. Turn that off, and yeah, we're only drawing 3 amps. With the signal generator on, we're drawing 5 amps. That's amazing. And that light is so bright, man. It's twice as bright as it is now when we run the signal generator. That is a lot of wattage. I'm looking at my piezo's real quick. I think I can see them trying to jump off the table. They're just being weighed down right now. That's awesome. Oh, where is it? There it is. 1,000 RPMs. When you put them together, you can get like 1,500, no problem. Well, actually, that was before I put the fabric softener sheets on the bottom of this thing. So I don't know if I can still get that. Well, you know what? Last time I tried, this thing kind of came out. Here, let me get you guys off the tripod now. Gotta plug you in too. I will respond. Oh man, let me think here. Well, I don't know. It depends on what you mean by the best. You know, you can grow it quickly, or you can grow the best. I mean, you know, you can try and do both. That's my kids. That's right. They're honor roll students. What do we want to do about them? I know. Back to the Future. I get it. Well, Back to the Future 2. Or is it the end of 1? I forget. Hell yeah. Impulse engines. Impulse power. That's what we need to get off this rock. Once we're off the rock, then we need warp power. But I think all those kinds of ships are built in space. No, this is actually, I have a really big bedroom, and this is just, part of my bedroom. Yeah, that's DC brushless motor right there. Nice. Yeah, DC brushless motor. And you can see we got some output. That light is hooked to the circuit that's running right now. All right. Oh man, I want to like do both of these, but I know it's going to go way too fast with the maglev. It's for the pull. It's going to go way too fast. If I take it off the maglev, I might be able to do it. Run both circuits because it'll cap out at about 1600 RPMs. Uh, without a maglev, but with a maglev, we're talking too fast for the pull. So, if you were here to see the demonstration with the smoke, it all the way up here, it's like sucking in. It's pulling down from all the way up there. So, I mean, like, as long as we got a real fan going in the room to circulate the air in the room, this thing will filter all the air in the room. Pretty sweet, I think, man. It's my bedroom air filter. It's freaking dope. We got what is it, like coastal breeze bounce on there, something like that. I'm thinking maybe I'll hook the signal generator up to the other circuit, the one that's running right now. Here, let me swap that up real quick so we can use it. Or no, wait. You know, you can kind of see that light a little bit better now. All right, let's turn this on. And we'll turn on the signal generator. Just kidding. And the faster the thing spins, the faster or the farther the suction is for the fan. But let's turn off the signal generator now and see if we can get some more speed. And that doesn't make sense in my mind. Higher frequency, more speed, right? But this is increasing in speed with so much faster with it off. Oh, I smell something. I'm gonna turn that down. It smells like a hot transistor to me. But it's really just a MOSFET on this. I call it a voltage multiplier. So it took that 55 watts, that we were looking at over here, and it changes it into actually this meter right here will tell us what it is when it's on. So right around 58 volts and that's after running the motor. So if I unplug the motor, this thing will read 75 volts. This is with the motor plugged in, and we're still getting 56. So that's good. Take a look at this meter here. So it looks like we need some condensers. Smooth that out a little bit. It's a little choppy. And then you get that little AC constant bump from the magnets. It does apply a little bit of energy to the whole thing. The magnet generation from passing the coil. It's a flow. It's like a flow matrix. So as soon as it's generated, it's used like immediately. It's just part of how it runs already. I'm pretty sure. Now there are different, like each one of these coils can have a BEMF collection connection, and it's virtually just a reverse diode connecting the two ends, the start and the end of the coil. And if you have like a trifilar coil, you can do 3 BEMF connections. You can do it's awesome, really. But you got to think each time you do one of these BEMF connections to collect it that way, you're gonna get. You can do it wirelessly too. You just wrap a coil, you get it real close to the center of the coil you're collecting from, and you can light an LED that way with the BEMF. But you do it this way, you're gonna get an effect of the coil. It's gonna slow everything down. Each one you do. And you can say no, 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 and then you turn the diode the other way and you're shorting the coil, or you take the diode all the way out altogether and you short the coil. You connect the two ends together and you've got a magnet there, like almost a permanent magnet. But I mean, there's a way to do it where it's just instantaneous and you get a burst of energy. It happens fast. But yeah, the BEMF connection, the reverse diode, you can link them together in so you can get them all on the same collection train, and then you can have them dump into like a capacitor bank or something. But I haven't done any of that because I'm not really looking to do that. I was just testing out the rotor. It is maglev. And seeing, I was trying for lift, but I'm sure I got the blades wrong for lift. Maybe they need to be a little wider and maybe a little bit less curved. They're very curved. You know, what I used to make them was looks like a trapezoid, but it's rounded on the top. Looks like a curb. And then I just hollowed that out with another curb that wasn't as big. And then I stretched it out to fit, and it fit quite nice. So that it almost looks like it's supposed to be that way, you know? But I can make these fins anyway, anywhere, you know, whatever I want them to do. And I'd say if I made them, straightened them out, you know, made it so it wasn't a fan, that this thing would go 2,500 RPMs. I'd be holding it like this, going, "Oh my God, how am I going to turn this off?" You know, like that. But I mean, yeah, that would be funny. And then there's only one way to turn it off when you got it like that, and that's to grab the wheel. Don't stick your hand in the middle. Oh. Yeah, I can see the humor in that. But this is what I want to do. I want to take the signal generator and clip it onto this one. Boom. Sweet. All right. Now let's pump 31 volts into this and turn the signal generator on. See if we can get that light to either brighten up or flash a little faster when it turns on. There we go. And 105 kilohertz. Here we go. Oh, it turned the light off completely. So we're going to drop it down, I guess. And here we go. We're getting close. Sorry. 1 kilohertz. That's awesome. That goes up to 10 kilohertz. 1 to 10, you get the harmonics. You get that sound wave, that screeching noise. Let's see if we can get the light back on above 105. Maybe we got to go the other way. Maybe it's not going to work with 31 volts. The other side, it works pretty good. Yeah. Nope. For some reason, the signal generator does not help this side at all. And that's with the 31 volts in. All we can do with that is drop the voltage. We can drop it. But, yeah, I'm going to take this and put it back on the other one. And what you do, you're hooking it up to the base of the transistor so that you can pulse it at your leisure. Frequency is the pulse. All right. Anybody want to try and figure out why the signal generator at 105 kilohertz does nothing for the one drive and like super duper helps the other one? Not for speed, but for generation purposes. I don't get it. I think it has something to do with how much voltage is going in, but yeah, it's got to have, well, all of it probably factors in. All right, let's get a look at the transistor real quick. Toshiba. I can't read it. Can't even see it on that one. No. It's a Toshiba. It's a high rating. It's got a high rating. It's not the MJL ones. I have some of those though, lying around somewhere. Uh, it comes 5 and 5, 5 MPNs, 5 PMPs. That's all I got right now. Now, about the circuit, it's got an attachment. You put the transistor in this little thing right here, and it extends how much, you know, area you have to clip on to each leg. I'm going to get that number real quick. I can't read it. If you can read it, there it is. I have no idea what you're talking about, Gothic. I'm not trying to sell it to anybody, so I don't know if it really matters. Yes, sir, that's it. Thank you, society. It's an air filter. It's a pulse motor air filter. See, these are blades right here. These suck air in through the filter and out the bottom. And in order to make it spin fast enough, we just turn on the pulse motor. It's really easy. Now let me explain the pulse motor. All right, we got a trigger coil here and a trigger coil here. These are both hooked up to the base of the transistors. We have two transistors, one here and one here. Okay, now let me explain which coils are hooked up to which transistor. This, this, and this. This is a 16 gauge, 24 gauge, and 20 gauge. These are all hooked up in series to this transistor over here. And then this one, the two gray ones, and that one adjacent are on the same circuit as well. This one actually has a bifilar situation. This one does not. So this one actually contributes to the drive of the said circuit. And it's two 90-degree circuits. So, and they don't hit at the same time. So what I'm saying is it goes 1, 2, right? So when they're on together, they function together. You know what I'm saying? They don't hurt each other because they're not firing on the same ones or at the same time even. Now, they're all touching each other with their fields by most certainly. They're close enough to interact with each other. But all that does is put energy into the coils. Like it shares the energy that's already there. So when a magnet passes the two trigger coils, it will fire off the circuit. Bada blam. There you go, James. That's it in a nutshell. Now we have this is like our only added resistance is the light bulb that I have in the circuit. It's a 120 volt halogen bulb. Let me think if I can. Our voltage multiplier for the one circuit. I had two of them, but one of them's broken, so now I only have one of them. I would have put it on the other circuit, and we'd have two 75 volt circuits. But what it does is it takes the wattage from the power supply, and it breaks it down into voltage, higher voltage rating. It's not all voltage that's coming out of this thing, but that's the rating that you can set with the adjuster, the voltage. Top of the morning, Mike. How's it going today? It's a good day, yes? So I got this bad boy magleved. I got, what do you call it? Fabric softener on the bottom of it. Yes, sir. Can't run that for very long with both of them for very long with the maglev on. It gets going to speeds that the pole cannot handle. Where did I put my? There it is. I'm gonna try and get a reading before I gotta turn it off. And I'm gonna put you guys back in the tripod. You need both my hands. All right, second drive. Here we go. Yeah, I think the maglev's it's too unsturdy the way it is. 'Cause I can get way more than that. Way more than that. I'm gonna try something. Maybe it's too high. I think it might be a little high on the coil. And then I'm just gonna put it back the way it was. Haha. Because I was getting almost 7,000 and it was sturdy. You know, divided by 4, of course. So there's your magnet. Let's turn it on and see what happens. No. Are you an idiot? Yeah, it's not right. I think the maglev's getting in the way. I mean, it coasts longer, but I don't think it's smooth to ride, no. Hmm. Wait a minute. Try backing these off just a little bit. Alright, so the positioning of the coils is how we're gonna do this. 3,750. Alright, there it goes. I gotta turn that off now. Shoot! Alright, here we go. I don't know if I'm gonna be doing too much more of that. I gotta hook this back in here now. I think I'm gonna glue that to what it's on and then move what it's on around. think I might need a glue stick. So this is like one of the last things I'm going to do before I rearrange everything in here. So. So cool. I don't think it's going as fast as I want it to. So now I'm going to do what I started with. I'm going to stack these little bearings up. They moved really good. I got like 10 of them. Fits right, nice. Right, it's like in the sweet spot, kind of. Probably use one or two more of them. The cool thing about this is I don't need to run it like I'm running it. I can use a paper clip to run it. And that's to make the rotor move. When I say run it, I mean the rotor is moving without you moving it. Yeah. Alright, so this is without maglev. Feels wrong. That magnet might be a little off center on there, so I'll have to reattach that. And it also looks like I'm gonna have to cut some stuff. And it's okay, this is the first one I'm doing, so this is like, I need to, it's not the first time I put stuff on the bottom of it, but like the first one I've done with the fan. Alright, let me see if I do this. That thing gets really hot, so I gotta turn it off before it gets too hot. Now maybe a resistor of some kind. So we moved them all into a 1/2 inch away. That's too close. I'll let it run for a minute. All right. I'm getting there. No. See, this is it, man. I was right about the maglev in the beginning. It was better just for now. It's all right. It's not moving very fast though. All right. Well, that was fun. Taught me a lot. Maglev for the win. Thank you very much, ladies and gentlemen, for tuning in. I really appreciate it. Thank you. And I'm going to do it for about an hour at a time. I'll catch you later. Bye now.